Welcome to Miss Smith's Math Tutorials. I'm Miss Smith. In this video, we're going to be talking about inverse functions. And when we create an inverse function, basically we're taking a function. In this video, we're going to show a linear function and a quadratic function. And we're essentially just reflecting them over the line y equals x. But we're going to do it in a way that utilizes 4 really easy steps. So the first step is to rewrite f of x as y. And I literally mean, instead of writing f of x, we're just going to write y, right? Because we can use those interchangeably. For number 2, we're going to switch the x and y. So we're literally just going to take the x and the y and we're going to switch places. Step 3, we're going to solve for y. So we're going to isolate the y variable at that point. And then as our step 4, we're going to rewrite y as f inverse of x. So that's an f with a little exponent, -1, of x. And we, again, pronounce that f inverse of x. So 4 pretty easy steps. So the whole thing about reflecting will make a lot more sense once we graph these. So I'm going to kind of show you how these look graph, and then I think it'll make a little more sense at that point. But first we're going to start just by finding the inverse. Eventually we'll get to this domain, range, and is it a function. But first we're just going to follow our 4 steps. So they want us to find the inverse of f of x equals 2x plus 8. So remember our first step. Rewrite f of x as y. So instead of f of x, we're going to just substitute in y equals 2x plus 8. Number 2, switch x and y. We are literally just going to switch these positions. So instead of y equals, I'm going to say x equals 2y plus 8. Notice I left the 2 the same, the 8 the same. I just switched the x and y. Step 3, solve for y. So now my goal is to isolate this variable y. And how I do that, I've got to remember my basic solving rules. So remember, if we've got a plus 8, we need to do the inverse. We need to subtract 8. And what I do to one side, I have to do to the other. Remember, x minus 8, those are not like terms. I can't combine them. All I can do is rewrite them. X minus 8 equals 2y. Remember, this is 2 times y, and how do I undo times? I divide. And when I divide by 2 on this side, I've got to divide by 2 on every single part of the other side. So x divided by 2, remember there's an understood 1 in front of that x, so you could either write this as x over 2, or you could write it as 1/2 with a little x on the side. Either way is fine. I'm just going to write it as x over 2. And this is -8 divided by 2, which is -4. And we got our equals y. So notice I finally have my y isolated. I solved for y. Step 4, rewrite y as f inverse of x. So I'm going to accomplish two things with this. I don't like the way that looks, so I'm going to flip it. I'm going to have the y come first, but instead of writing y, I'm going to write what I know I need to write with my answer, f inverse of x equals, and now I'll put my x over 2 minus 4. And this is my inverse function. So remember, this was the original, and this is the inverse. So I'm going to show you how these look if we were to graph them. And I'm going to use my graphing calculator to help me. So I'm going to pull that out and cut it on. Remember, I go to my y equals for any graphing I want to do. And I'm going to first start by putting in what they originally gave me. So the original equation was 2x plus 8. And my second equation is going to be my inverse. So this is what I found. So x divided by 2 minus 4. And I'm going to graph. I just want to see what these look like. So that was my first, that was my original, and look, that is my inverse. So hopefully you notice they're kind of forming a reflected image. So if I were to take, and I'm just going to use a ruler, if I were to take a really thin line and create a line right at y equals x, right? So that's a diagonal line cutting right through the origin with a slope of 1. And notice that it creates like a mirrored image of those two. They're reflected over that center line. So that's what we're doing when we're creating an inverse. We want to find that reflection. So that kind of, hopefully that gives you a general idea of what we're trying to create here. The last thing we want to do with this problem before we move on is we do want to be able to say what's the domain and range of the original, as well as what's the domain and range of the inverse. And are they both functions? Is one a function and one not a function? You know, how does that work? So there's actually some cool tricks, some time-saving shortcuts that we can take here. So I want to show you those. When we come to our original, when we want to know our original domain and range, bring back my graphing calculator, and I'd want to go back to my y equals. Now, I only want the original one, so I cleared out my second line. I cleared out that inverse function. I just want to look at the original. And I'm just going to graph that. So there was that just original line. That is a linear equation. It extends on forever. It doesn't stop just because the window stops, right? There are errors there. Keep going on forever. So remember, to find domain and range, we read domain left to right, range bottom to top. If you need a refresher on domain and range using interval notation, please check out that video. I'm not going to spend a ton of time explaining it on here because I'm assuming this, if you're watching this, that we've already spent time on domain and range, but you may need to go back and review that video. All right, so for my domain and range of my original, left to right, so from the left, I see the first thing I touch is negative infinity. Remember, negative infinity and positive infinity always get parentheses, never brackets. And when I read from the right, first thing I touch is positive infinity. All right, so my domain is all real numbers, negative infinity to positive infinity. All right, the range, first thing I touch, an arrow, so that's going to be my negative infinity. We also hit an arrow, so positive infinity. And then what's really cool about this is once we find my domain and range of the original, I can already tell you the domain and range of the inverse without even having to graph it. And what it is literally, because remember, inverse means opposite. So if I bring my domain down here to the range, right? So I'm going to bring that domain down here, negative infinity to positive infinity. And I'm going to take that range and I'm going to put it up here in the domain for the inverse. Negative infinity to positive infinity. Done. So you can just switch. Okay, now I know most of you are probably thinking they were the same. Right? And so when you switched it, you didn't really change anything. And you're absolutely right, because the linear is domain and range, both all real numbers. Okay, so you'll see that when we do our second example, that we do see a difference there, and you can kind of clearly see that switch. So we can prove that to you by graphing it, and I'll show you that in just a second, just to prove to you that it does in fact switch. And for our function, we also have kind of a cool trick with that too. So in the original, we would pull that out, and I've still got that original graphed. And I would say, how do we tell if something's a function? Well, we see, does it pass the vertical line test? So when I hold a vertical line like my pencil, and I pass it through the line, does it hit that line more than once at a time? And hopefully you're seeing no, right? So when I pass that vertical line through, it only ever hits the line once. So that means it is a function, right? It passes the vertical line test. And when we want to find out the inverse, if the inverse is a function, without even having to graph it, there's a way to tell. And it is called the horizontal line test. So it's very similar to the vertical line test. It's just that instead of having a vertical line, we have a horizontal line. It follows the same parameters a vertical line test would. We're asking the question, would it hit the pin more than once at a time? So when we do this horizontal line test, does it ever pass the pencil more than once at a time? No, it doesn't. It passes the horizontal line test, and therefore the inverse is also a function. Now, just to prove to you that these statements are true, because so far we only graphed the inverse just to kind of show you how it looked, but we didn't really double check it at all. I'm going to put in the inverse. So that was x over 2 minus 4. And we're going to graph it just to prove to you that these are true. So there's that inverse line. And if we check the domain, it is negative infinity to positive infinity. The range is negative infinity to positive infinity. And it is a function. It does pass that vertical line test. We used the horizontal line test on the original just to see, and we're now proving it. That yeah, it is a function. Okay, looking at our next example. So they want us to find the inverse of f of x equals x squared plus 3. So remember, we're just finding the inverse right now. We're not worried about domain and range yet. We're going to go back to these steps. So they say rewrite f of x as y. So instead of f of x, I'm going to write y. Number 2, switch x and y. So I'm literally just going to switch their places. So I'm going to put x in the place of y and y in the place of x. And notice what I did there. I left the square. Okay, the square didn't go with the x, right? It stayed right where it was. Step 3, solve for y. So we got to isolate this y. And in order to do that, I'm going to use my basic solving rules. So I'm going to subtract 3 from both sides. And this is x minus 3, and I can't combine those, so I'll just rewrite it as x minus 3 equals y squared. Now here's the thing. I don't want to know y squared. I want to know just y. So how do I get rid of that little 2? We have to remember that the inverse of a square is a square root. And when I take the square root of y squared, it's like canceling out that little 2. But I can't just take the square root of one side, right? I've always got to be fair in math. If I'm going to do the square root here, I've got to do it here as well. Now what's important to remember is that anytime we take the square root, we are left with the positive and the negative version of that answer, okay? So let's rewrite this. So our y is isolated at this point. I got rid of the little 2, right? So I have y equals the positive and negative version of square root of x minus 3. And that's going to be very important, and I'll prove to you why on the calculator. And then my final step, rewrite y as f inverse of x. So instead of y, I'm just going to write it as f inverse of x equals positive or negative square root of x minus 3. And that is my inverse. Now, I want to take a moment here and pull out my graphing calculator, and I want to show you how the original and the inverse look. And remember, anytime I want to graph, go to y equals, and I'm going to first type in the original. So x squared plus 3. That was my original equation that they gave me. And then in my second line, I'm going to type in the positive version of square root of x minus 3. I can't do plus and minus in the same line. At least I don't know how to do that. So I'm going to do the square root of x minus 3. And notice the x minus 3 is all underneath that radical. And then I need to come down to the second line, and I need to also do the negative version of square root of x minus 3. So notice what I did there with line 2 and line 3. I gave both the positive and the negative version, which is what my answer should have been. Okay, and let's graph it. Let's just see what happens. So there's my original. And look, there is my inverse, the one facing to the side. So again, if I were to hold over this a line that went through, that falls at y equals x, you see how the picture is reflected over that diagonal line. So I want to just make a quick point to show you something, because a lot of students do this by accident. I'm going to just show you that a lot of students forget to have that negative version, and they just have the original and then they have the positive version. And let's just see how that would look on a graph. So I'm going to graph. So there's the original, and look at that. Notice that's only half of the picture, right? So that's the positive version, but we need the negative version as well to complete the picture of the inverse. Okay, so I always think that's kind of cool to really prove to you why we need both the plus and minus. So anyway, that's probably the math nerd in me, but I think that's pretty cool. So let's move on over to our domain and range. So remember, we want to know the domain and range of the original, and then we need to find the inverse. So I'm going to pull out that graphing calculator, and I'm going to fix this. I'm going to make sure I have then that negative version as well. Okay. So remember, this right here was the original. So if I want to know the original domain and range, so I'm not focused on that one facing to the side, just the top one. When I look at it left to right, I see I get negative infinity to positive infinity. And for my range, from the bottom to the top, that starts right at positive 3. It is a solid point, which means it gets a bracket. And top to bottom, I get a positive infinity. Now what's cool is, with the inverse trick, I can go ahead and tell you what the domain and range of the inverse are just by switching them, right? So this bracket 3 to positive infinity is now going to be my domain. And this negative infinity to positive infinity is now going to be my range. And we can prove it. We've already got that, the inverse graph, so we can just look through it real quick. Doesn't the domain start at positive 3 and end at positive infinity? Yep. And doesn't the range begin at negative infinity to positive infinity? Yep. So we just proved that that was true. And then for my function, is the original a function? Well, looking at it, the original, this top one, does it pass the vertical line test? Sure does. Yes, it is a function. What about the part 2 though? What about the inverse? So I could either look at the inverse, okay, I can tell that's not a function, or I could give the original a horizontal line test. Would the original pass a horizontal line test? And hopefully you can see no. So whatever way you want to go about it, the inverse is not a function. We're going to look at just 2 more examples for inverse functions. So looking at this first one, they want me to find the inverse of f of x equals 1/3 x plus 7. So I know we don't have the steps on this page. You may need to look back if you need a review, but I'll walk through them. that instead of f of x, we're going to write y equals 1/3 x plus 7. And then remember, we want to switch the x and the y. Just switch places. And then we want to solve for y. So I want to isolate my y variable. In order to do that, I'm going to subtract 7 from both sides. And x minus 7, remember those are not like terms. I cannot combine them. I can just rewrite them as x minus 7 equals 1/3 times y. Now, different people have different approaches to this, but I always like to think of it as this is 1/3 times y. How do I undo times? I divide by 1/3. And 1/3 divided by 1/3 is 1, right? It just cancels to 1. And if I'm going to divide by 1/3 on one side of the equation, I've got to do it on every part of the other side of the equation. 1/3. And 1, because remember there's an understood 1 right there. 1 divided by 1/3 is actually 3. And if you're not sure about that, remember, you've always got your calculator, right? We could do it manually by hand, but, you know, if we've got a calculator, we might as well use it. 1 divided by 1/3, 3. Okay, so we can make quick, light work of that. 3x. Remember, we've got that x with it. And then negative 7 divided by 1/3 is actually negative 21. But again, I can show that. So we've got negative 7 divided by 1/3. Okay, negative 21 equals y. And remember, our final step is we want to rewrite this in a way that looks a little better by putting the isolated variable first, and at the same time I'm going to switch it out with an f inverse of x equals 3x minus 21. There's our inverse function. When we want to find the domain, range, and function of the original and the inverse, so we could definitely find the original pretty quickly. I know there are some of you that are looking at this and thinking, that's a linear equation. It's not a horizontal line, and it's not a vertical line. So the domain and range have got to be all real numbers, right? And you would be right. Some of us are not quite there yet, and that's okay. So if you need to, grab out your calculator and type that into your y equals 1 divided by 3x plus 7. And look at the picture if you need to. Okay? Walk through the process. But this is a linear equation. Our domain is negative to positive infinity. And our range is also negative to positive infinity. And if we wanted to do the inverse, we know we can make quick work of this by just switching. Whatever we have in the range is brought up to the domain, and whatever's in the domain is brought down to the range. In this case, they're the same, so we don't really get to see a cool change there. But and is it a function? So if we have a linear equation, and again, we may need to look at it, it's a linear equation, yeah, it's a function. Passes the vertical line test. And if our original is a linear equation, well, guess what? Our inverse is also a linear equation. And our linear equations functions, as long as they're not a vertical line, yeah. So, yes, the inverse is also a function. Let's look at one more example together. So we want to find the inverse of f of x equals 2x minus 3 over 5. So I find that students tend to be really scared when they see stuff like this because it's a fraction and it looks scary, but fractions really aren't scary. We've got ways to undo them, okay? So we're just going to follow the steps. Remember, instead of f of x, we're going to write y. Keep everything the same right now. And then we switch our x and our y. So we're going to have x equals 2 times y minus 3 over 5. Then we want to solve for y. I want to get y alone. Okay, and remember, we can get rid of a fraction by multiplying the whole thing by whatever's on the bottom. Okay, so in this case, on the bottom is 5, so we times the whole thing by 5. And when we do that, it cancels out. Now, common student error is people want to take this 5 and they want to multiply it by the top. No, no, no. We've used that 5, right? We're multiplying it by the bottom, and we're done. That 5 is done. Okay, and all we have left is what's up top. But if I'm going to multiply by 5 on this side, got to do it on the other side too, right? Timesing by 5 there. So 5 times x is 5x equals, and remember, all I have left is the numerator. I got rid of the denominator. 2y minus 3. And then from here, it looks much like the other problems we've been solving. So I'd want to add 3 to both sides. 5x and 3 are not like terms. So I just rewrite 5x plus 3 equals 2y. My final step to get y alone is divide by 2. And I typically would show this as, and I kind of moved a little fast there, I would show this as 5x divided by 2, right? 3 divided by 2. Either way is technically correct. I like showing this way when I'm teaching it to really break it down, but sometimes when I'm moving quickly, I'll do the whole thing. Either way, here it doesn't really make a difference. 5x divided by 2, well, 5 over 2 does not reduce, okay? So since it doesn't reduce, I just have 5 over 2x, right? And positive 3 over 2, well, that doesn't reduce. So I just have positive 3 over 2 equals y. Remember, that final step is I want to make this look a little better, and while I'm doing that, I'm going to sub out the y for f inverse of x equals 5 over 2x plus 3 over 2. And that is my inverse. When we go to do my domain and range of the original, some of you may be asking, is that a linear equation? It sure is. I know it looks weird, okay, but really this is just 2/5 x minus 3 over 5. That's technically an mx plus b. But if that confused you, and if you're like, man, I'm not there yet, that's totally fine. Bring out your graphing calculator, graph the original. And the way we'd put that in the graphing calculator is you'd use parentheses, so you do 2x minus 3, close the parenthesis, that shows the calculator, that's the numerator, and then we want to divide by 5. Okay, that's one option of plugging it in. And we would graph it, and I see at that point, oh, it's a linear function. And linear functions always have, well, I shouldn't say that, linear functions that are not horizontal or vertical lines always have a domain and range of negative infinity to positive infinity. So I can go ahead and fill that in. And my inverse is just going to have that flipped. Now in this case, it doesn't make a difference, but it's still what's happening. Is the original a function? Yeah. It is a function. It passes the vertical line test. And let's review that horizontal line test one more time so I can look at the original and I can tell if the inverse is going to be a function by that horizontal line test. Would it hit my pen more than once at any given time? Nope. So it passes. Yes. The inverse would also be a function. All right, so here's one for you guys to try on your own. I want you to find the inverse of f of x equals 2x plus 4. So I want you to find the inverse using the steps, and then I want you to tell me the domain and range of the original, plus is it a function, and then tell me the domain and range And is it a function of the inverse? So I will post the answer in the video description below. This has been Miss Math Tutorials.